guys, welcome back. Today's lesson is going to be about decimal extension. How do you solve a problem when there's a remainder, only we're not using remainders anymore? So I'm going to get into that in just a minute. Before I do, there's a shout out from Eliana to Sosi. She says, thank you for spending time with me. All right, let's get into it, guys. All right, here we are in today, lesson 37. I call it decimal extension. The book calls it adding zeros. So one thing you want to think about is how numbers can come and look differently but have the same value. For example, if you had a $5 bill and you had 5 $1 bills, even though they look different, they have the same value. A $5 bill is the same as 5 $1 bills. So it's the same thing here with the number 38. 38 means also, if I had 38 and I added a decimal and a zero, even though these look different, these have the same value. They're both worth 38. Because remember, at the end of every number that doesn't already have a decimal in it, the decimal goes at the end of the number. So every number that doesn't already have a decimal, it goes to the end. So here I've added a decimal and a zero. I could also add 0 hundredths or 0 thousandths or as many zeros as I need. And this value and this value is the same. They just have some zero placeholders in it. So same with 15.2. This number already has a decimal in it, so I can't move the decimal or it wouldn't be the same value, but I could add more zeros to the end after that number, and these have the same value, okay? These didn't change. They're worth the same amount. If you went and were comparing them, these would be equal to each other. So that idea of adding zeros and having a number have the same value is one we're going to use when we're doing decimal extension or adding the zeros division where we don't want a remainder. So I'm going to keep working the problem until I no longer have a remainder left over. So I have this number right here, 8 going into 78. So first thing, I go through my does McDonald's serve burgers or my extension, decimal notation, expanded notation is what we called it. So I go through the same process. Can 8 go into 7? It cannot. Can 8 go into 78? If I know my multiplication facts or if I have my multiplication chart, I know the closest I can get without going over is 9. 9 times 8 makes 72, which is under 78. So on top of the 8 goes the 9. Remember that where you place the numbers is important, especially since we're going to be having a decimal being added to this, so we need to make sure we keep track of where things are. So 9 times 8 gives me 72. Multiply, subtract, and I get 6. Well, this is decimal extension. It is not where I'm going to write a remainder. I'm not going to write remainder 6. I'm not going to write 6 over 8. I'm going to keep working this problem until I no longer have a remainder. So what I'm going to do is I'm going to add a decimal. Okay, 38, 38 point, same value. 78, 78 point, same value. And I'm going to add in a 0. I'm not going to add in 5 zeros. I'm only going to add in as many zeros as I need to keep the problem going until I don't have anything left over. As soon as I add that decimal in, I want to add that decimal to the top of my multiplication problem because that's where the decimal goes. And decimal problems have decimal answers, so I don't want to forget that decimal because if it's not there, it's not right. So now I'm going to bring down this 0. And I have 60. So how many 8s can go into 60? Well, the closest I can get without going over is 8 times 7, which makes 56. 8 times 8 is 64, and that's too big. So put a 7 on top. 7 times 8 gives me 56. Subtract, and I get 4. I still have a remainder, so I'm going to add another 0 and see if I can get rid of that remainder. So here, how many 8s can go into 40? Well, 8 times 5 is 40. And now I have nothing left over, so I don't need to keep adding zeros. Do you see why you only want to add the zeros as you need them instead of keep adding and adding and adding zeros? Because then you'd have to keep this problem going on and on and on. So you only add as many zeros as you need to finish the problem so there's no remainder. All of these problems will have no remainder because you're going to put the decimal in or add zeros to the end of it if it already has a decimal, and solve the problem until you get nothing left over. All right? So my answer here ends up being 9.75. All right, the problems for today are page 163, problems 13 through 17. Page 163, problems 13 through 17. All right, guys, I'll see you on the next one. Bye.